Hi everyone, welcome back. This is lesson 3, writing equations of functions. What I'm going to do to get you all started is I'm going to actually ask you to pause and work through the opener. So for this opener, I'm asking you to describe the differences in the graph to the right compared to its mother function on the left. And go ahead and do that in the box provided. So go ahead and hit pause, work through this, and I'll see you back here in just a second. All right, welcome back. Here are the transformations that you should have identified. Some are pretty obvious, like we can easily see that the graph on the right has been flipped or reflected. Probably a better word to use there is reflected rather than flipped. But I think that one's pretty obvious. The other ones that we can see pretty clearly is that if we look at just kind of the starting point of this graph, right, it's been shifted to the left 3, right, it's -3, and then also down 4. So that's going to be our horizontal and vertical shifts. So I think those 3 things are pretty easy to see, but this last one, a little bit trickier. So because it is reflected or flipped, it's hard for us to really determine is the A value, has that been affected rather than the sign just changing. And so one way that we can do this is if you go right 1, how far up or down do you have to go? So in our mother function, if I go right 1, I'm only having to go up 1 to run into a nice even point. Now, what I mean by a nice even point is that it intersects at whole numbers, right? So this is 1, 1. We don't want to run into 1, 1.5 because then we're just kind of estimating. So we always want to make sure we're getting to a nice even point. So in the graph on the right, if I go to the right 1, I'm having to go down 2. So that's telling me that this is a little bit steeper, right? I'm having to go down a little bit further than what I was in the mother function, which is going to affect that A value. So why are we doing this? This is what's going to help us to ultimately write the equations of all these mother functions. So how can we use this information to write the equations of this function? We can identify the A, H, and K value based on the transformations. So that's our ultimate goal, and that's what this lesson is going to get at is if I give you a graph, can you go ahead and write the equation? Now, there's a lot to this, right? We've already learned 8 mother functions, and all of that is still a factor. And there are kind of little bits and pieces that are unique to each function, but for the most part, we're going to be able to identify H and K pretty easily for all of them. The A value, there's going to be a little more work, but it's just really important that as we continue to move through this unit, that you know all 8 mother functions. So up to this point, you should know that the 8 names, the 8 equations, both their mother functions and also an HK value. And now we need to start getting a little more familiar with what each graph looks like. If you're looking at the graphs and you're not sure what function it is, it's going to be pretty tricky. So if you're not there yet, not a big deal, but this is something you're going to want to work on over the next couple of days so that you know what each graph tends to look like. So last piece, what are the equations of the 2 functions above? Well, the one on the left, the mother function, this is a square root function. So we're going to write y equals square root of x. And then the right equation, we're going to go ahead and add in these a, h, and k values based on the transformations we identified earlier. So we're going to say that y equals, I'm going to go square root. I'm going to leave some space for this a value. We'll come back to that in a second. And it's x. Remember, we always want to put that horizontal transformation next to the x value. So if I went left 3, right, usually we would think that's -3, but that sign needs to be the opposite. So we're going to actually say x plus 3, representing our shift of left 3. And then down 4, that's our k value. That's going to come after that function operation, so -4. And so we've taken care of h and k. Now for a, we know for sure it's going to be negative because it has been reflected or flipped. But then the next piece is what is that actual number? And that goes back to what I was talking about earlier is if we go right 1, how far up or down do we have to go? Whatever number that is that we have to go to get to that nice even point should be our A value. And we're going to actually have to find a way to verify that, which we're going to do in our future examples. So in this case, if I went right 1, I had to go down 2. That's going to actually be that A value. That A value tends to be the trickier part of all this. And again, we're going to add in another element to make sure that we're finding that correctly. So this is what we're going to do for this next lesson is write equations of any graph. When we're doing this, we want to identify which function. That's always got to be where you start. If we don't know what function we're looking at, it's going to be pretty hard to write the correct equation. Identify our vertical and horizontal shift, doesn't really matter what order, and then identify the a value. And what we're going to do is we're going to use a point or two to verify. That's going to be something new. This is where we're going to actually start doing a little bit of algebra. It's been a while since we've all had to do some order of operation work, but that's what we're going to get into right now. So go ahead and flip this page over, work through each of the whole class examples, and then possibly even one of the group examples. Okay, so looking at this function, it should be one that's familiar to you. We definitely did a lot of work with this in Algebra 1, probably even a little bit in geometry. This is a quadratic function, right? It's got that U-shaped, should be pretty easy to identify. So when I'm going about these, I'm identifying like a key point. And usually that's going to be a turning point or something that happens right in the middle. So in the mother function, that key point is always going to be at 0, 0. So we want to figure out where did we go from 0, 0 to get to that next key point. So in this case, right, that vertex is at 4, -2, which is our h and k value. Most of the work's already done. Now, there's a lot more that we have to do to find that a value and then to go ahead and verify it. So let's go ahead and just write what we have so far, and then we'll take some time to figure out what this a value is. So I'm going to leave space to fill in for that a value here in a second. In parentheses, I'm going to say x, and then our horizontal shift, or our h value, which is 4. And since it's to the right, I'm going to switch that sign, make it negative. In order for this to be a quadratic equation, we need those parentheses to be squared, so don't forget that piece. And then our vertical shift, or the k value, comes at the very end, so -2. So now we have most of the equation. Now we're just looking on finding this a value. Just like what I had said previously, if we go to the right one, how far up or down we have to get to run into that nice even point should be that a value. So in this case, I went right 1. I had to go down 2. So I'm guessing that that a value is -2 because of me going over 1 and down 2 to run into that nice even point. Now, this is really just a really good guess. We want to make sure that this is 100% correct. So now we're going to figure out or verify that this is 100% right. Now, on the previous page, it said we're going to pick a point or two to help us verify. So what does that look like? We want to find, once again, a nice even point that falls on the graph, anything besides the vertex. And we're going to go ahead and plug that into our equation and make sure that they're agreeing. And I'll tell you exactly what I mean by that. So let's go ahead and pick this point here, which is 3, -4. And what we're going to do with it is, remember that all points are just an x and a y value. And so what we're going to do is we're going to take the x value of 3, and we're going to sub it into what we think is our equation. Same thing with the y value, -4. We're going to sub it in for y. And we're going to make sure, do we get something that is a true statement to help us verify this a value. So we're going to use the point 3, -4. Now I'm going to sub this in to what we think is our equation. So -4 is y equals -2. 3 minus 4 squared and -2. Right, so really, we're just working on simplifying this right side using order of operations. Think back to PEMDAS. I know it's been a long while since you've had to do that. But remember how this needs to go, right? Parentheses first, exponents, multiplication, division, then we end with our addition and subtraction. Really, really important that we go through this one step at a time and get this correct, because otherwise, if we mess up these operations, we're going to think that our a value is off or something else. So let's go ahead and do our first operation here, which is to simplify the parentheses. So 3 minus 4 is -1. It's still squared. So right, all I did was simplify the parentheses, doing one thing at a time, especially early on. It takes us a while to get our brains warmed up, remember how all this works. So don't do too much too early. Next thing is after parentheses is exponents, right? We have -1 squared. Remember what it means to square something, and that's to multiply it by itself. So it's really easy to mess these up. So if we stop and think about it though, what is -1 times -1? It's actually gonna be a +1, right? Negative times a negative is in fact a positive. Okay, always stop and think, what does it mean to square something? Right, then we have multiplication. If we do not have an operation between parentheses and a number, it's multiplication there. So this is -2 times 1. So we're going to go ahead and write that out, which is -2. And we're going to subtract 2. And just like we wanted, -2 minus 2 is -4. These agree. This is exactly what we were hoping for, is that we get a true statement, right? If you have -4 of something, I have -4 of something, we are equal, we have the same amount. So this has been verified. Okay? This is exactly what we're looking for, is that both sides agree. Now that tells us that this equation is 100% correct. So this is our way of checking to make sure that we're writing equations. So this definitely takes some getting used to, but when we're verifying the A value, you're going to get an idea is, are you getting the hang of this right away? Okay, this does make a big difference. Now, again, go slow when you're using your order of operations and thinking about doing everything in the correct order, because if it's not in the correct order, right, then we tend to get lost a little bit. Right, let's go ahead and move down to our next example. With this one, this is a newer function, and one that if you need to look back to your 8 mother function sheet that we did in our first lesson, feel free to do so. Okay, and we're still giving you time to familiarize yourself with these graphs, equations, and names, but we need to start being able to look at these and say what kind of function it is pretty quickly. So this is actually our cubic function, and for us in the cubic function, that key point is going to be right in this flat section, and usually right in the middle. Remember that if we look at our mother function sheet, this key point that I'm talking about always starts at 0, 0. So we're just trying to figure out, how do we go from 0, 0 to where that point is now? So this key point is at -5, 4. And now this is where, if you know what the graph of the cubic looks like, you would say, hey, it actually is supposed to be going up as we go to the right and down as we go to the left. So this has actually been reflected. Now, part of that is just me knowing what that graph looks like, but we're going to also be able to identify it by using that same process of going right 1, how far up or down to get that next nice even point, and it's -1. So even still, if I go right 1, it's something to go down 1. So I'm thinking my A value is -1, and we're going to go ahead and verify that here in just a second. So let's write what we think the equation is, which is y equals -1. X, I'm going to switch the sign of my horizontal transformation, so +5. It is cubed, and then +4. This is our guess as of now. We're going to go ahead and pick a point to help us verify, and then hopefully we're all set. Now, when you pick a point, it can be anything. It doesn't need to be the exact same one as me. But I like to find one that's different than my starting point, or that key point, which is, let's try -4, 3 as our x and y. So we're going to use -4, 3. I'm going to plug -4 in for x, 3 for y, and we're going to see if we get both sides to agree like we did on our last problem. Right, so once again, the operations, or the order of operations, is going to look the exact same as before. So we're going to simplify the parentheses. -4 plus 5 is 1. Still cubed, and then +4. Now, again, we have an exponent. It's a 3. We want to think about, what does it mean to take something to the power of 3? It means to multiply it by itself 3 different times. So if we think about what is 1 times 1 times 1, well, 1 times 1 is 1. Multiply it again by 1, and we just end with 1. So that actually does not change, because 1 times 1 times 1 is just 1. Next, we're going to go ahead and do that multiplication. So multiplying the number in front of the parentheses by the number inside. -1 times 1 is -1. And we have +4. So after we go ahead and add -1 and 4, we get 3 on both sides, meaning that they agree that this is a true statement, right? If you have 3 things, I have 3 things, they're equal, they're the same. And so this is verified. This is the correct equation for this graph, right? So really, really nice that we can verify this and confirm that the equation we wrote down is correct, right? So let's actually go ahead and do one more of the group examples, and then there's a little bit more left for you to do on this page, and then a bunch of individual practice. So we're going to actually skip the absolute value we'll let you take care of that one either in class or on your own. I want to jump down to this other function because this one's completely new and a little bit different. So this is actually our rational function, and it looks much different than all the rest. So there's a couple things that are very different with the rational function compared to our other 7 mother functions. And one of those properties is that these have asymptotes, and something that we've identified earlier. And what those asymptotes are invisible lines where our graph won't cross them, or won't touch them. So we actually want to fill those in. And how I fill those in is I try to find where is the graph flattening out or getting really close to, right? And it's getting really close to this line where x is 3, right? This vertical line of x is 3. So if I draw that line there, I'm not touching the graph, but I'm right in between those branches almost perfectly. We have another asymptote where y is 4. That's a horizontal line. And again, it's right in between those 2 values. So really helpful if we can put those asymptotes in the graph. And the reason for that is the intersection of those 2 asymptotes. It's going to be that key point that I keep talking about. So in this rational function, the key point, or where the 2 asymptotes intersect, is where x is 3 and y is 4. So we want to see those. This is our h and k, and we want to see those values when we go ahead and write our equation. Now the next piece, how are we going to find the a value? Well, just like every example we've shown, if I go right 1, how far up or down do I have to go to get to that nice even point? I have to go up 2. So we're thinking that our a value is 2. So how does this look? Again, rational is a little bit weird. If we're going to put the a value up top, so that is 2. That's one of the main differences between rational and the rest. Doesn't come directly after the equal sign. It's the top of the fraction. On the bottom of this fraction, we need to have our x there. And then we're going to include our horizontal shift of 3, remembering to switch the signs. So that's x minus 3. And our y value of 4, okay, or excuse me, the k value of 4, which is our vertical shift. So now let's go ahead and verify. Nothing is different here. We're going to pick a point. Let's go ahead and do the one that I've already drawn on there, which is 4, 6. Just to make sure that we in fact have the correct a value and the correct equation. So we put 6 in for y, 4 in for x. We're going to look to simplify. Now, this is a little bit different. You look at this and you're like, what operation do we do first? And actually, if we have a fraction like this is something we need to take care of. So we want to simplify both the top, which, right, the top's already simplified, no operation there, and also the bottom. So the first thing I want to do here is actually subtract 4 minus 3, get 1. We want to simplify that fraction as best we can whenever we have them. Okay, so 2 divided by 1 doesn't change, right? Divided by 1 doesn't do anything. So it's just 2. And then we have plus 4 and 6. So actually goes pretty quick once you know to simplify the bottom of that fraction, just like we were expecting, right? We got sending on both sides, so that is verified, and that equation is all done. All right, that is all I have for you. Again, you have one more problems to do in the group practice, and then a bunch on the individual practice. In the meantime, continue to familiarize yourself with the 8 mother functions, the names, the graphs, and also the equations. Have a great day.